All right, here we go with 6th grade Excel lesson number 25. We're going to be looking at the sum of the angles of a rectangle, right, obtuse, and acute angles, measuring and estimating angles. We're going to look at equilateral, isosceles, and scalene triangles, and the sum of the angles of a triangle. So a lot of stuff having to do with angles and shapes today. When two lines cross, an angle is formed. Angles are measured in degrees using a protractor. A protractor is that thing that looks like this. You probably don't have one at home, and it's got the little degree marks that go around there like that. The two lines shown on the right are perpendicular. Notice that this forms four 90-degree angles. What do you think will be the sum of the angles of a rectangle? This angle right here is exactly, it's called a right angle, and it measures 90 degrees if we were to measure that on this protractor. What we would do is take one part of the angle and it would go right along here, and the other part would come straight up there, kind of like that, and right up here on the protractor there's the number 90 written, and so we'd know that it measured 90 degrees. So knowing that, what do you think are the sum or the answer to an addition problem of the angles of any rectangle? Remember, this could be a rectangle too. If I were to add up these four corners, what would it come out to be? Pause the video, write your answer right here, and then turn the video back on when you're ready for the solution. All right, they would add up to, there are four right angles, and they're all 90 degrees. So it's 90 times 4, which is 360 degrees for the angles, the sum of the angles of a rectangle, or 90 plus 90 plus 90 plus 90. Okay. Remember that a line continues in both directions without ending. The following notation is used. So when we have line AB, it's going to look like this. The letters AB, line with arrows on top as the symbol showing that it's line AB. Remember, the A and the B should be capitalized because they're capitalized here. Or you could write BA, the order of it doesn't matter. Here's segment BA or AB. Notice the symbol on the top does not have arrows on each end because the segment does not have arrows on each end. An array goes in only one direction, and we'd write either AB, and notice that the arrow is pointing that way as the symbol because it starts at A and it continues past B, or BA, and notice in that situation I put the arrow pointing back this way because again it starts at the A and goes back towards the B, but it's not really going backwards in this way, in this situation, but that's fine. The order that you put it in doesn't matter as long as you have the arrow pointing the right way. On the right, the two rays AB and AC have the same endpoint. They have the same endpoint right there. They form an angle called a vertex. This part right here is called a vertex. AB and AC are the sides of the angle. This is a side of the angle, that's a side of the angle. The small arrow indicates the angle that is being measured. That's this little arrow right here. We're measuring this part inside those two rays. The following notation can be used to refer to this angle. I can either call it angle A because A is at the vertex of the angle, or I can call it angle BAC because it starts here, BAC, like that, or I can call it CAB, CAB. I cannot call it angle ABC. This is a no-no because that would be starting here, going up to the B and then down to the C, and that's not the angle I'm talking about. I'm starting at B, then going A and C. It has to have the A in the middle. Notice we have an A in the middle there because the A is the vertex of the angle. Angles can be classified into three different groups. We have right angles. That's a perfect corner like that, like the corner of your paper. You can see that this is a right angle, that's a right angle, that's a right angle right there. There's lots of right angles in this world. And then we have obtuse angles. That's any angle that's wider or more open than a right angle. A right angle would be about right there on this side. And you can see it's more open. I remember that as being like obtuse, like obese. Obese is big, so this is an obtuse angle. And this is a cute little angle because it's actually smaller than a right angle. Here's where a right angle would be. It's kind of closed, a little bit more closed than a right angle, so that's a cute little angle. It says, how do the acute and obtuse angles compare to the right angle? Well, I just gave you the answer to that question. I'd like you to write that here and here. How does an obtuse angle compare to a right angle? And how does an acute angle compare to a right angle? Write your answers in there, pause the video, and then turn it back on when you're ready for the solution. All right, you should have written this. Oh, thought I had it on there. Okay, should write that an acute angle is smaller or more closed than a right angle. An obtuse angle is bigger or more open than a right angle. There you have it. Measure each of these angles with a protractor. All right, well, probably don't have a protractor at home, so I'm going to put a protractor on top of this and help you to learn how to measure it using a protractor. So I'm going to pause the video for a second here, and you won't even notice the pause. I'm going to pull out a protractor and we'll measure it kind of together. All right, as you can see on the screen, I pulled out a protractor, and this, whoa, don't want to do that. I want to grab my protractor. I'm going to move it up here. The crosshairs right there that you see where it comes down this way, and there's a little line there, and there's a big line going all the way across there. That is the spot where I have to put the vertex of the angle. So I'm lining that up perfectly with the vertex, and you can see that this line coming out this way is not perfectly on the line on the protractor. So I have to pull this down just slightly so that it's perfectly lined up with it. Now what I'm going to do is follow the other line that comes out this way here, the other arm or side of the angle, and as you can see it points way out to right there where I just put that blue dot. Now I know those numbers are a little bit hard to see, but the number on the top that you see right here says 50 and the number on the bottom says 130. So we have to decide, is this angle 50 degrees or is it 130 degrees? Now, remember, that is a 90-degree angle. The angle we're measuring right now looks like this. Okay? Is this angle that I'm measuring going to be larger or smaller than 90 degrees? Well, it's been opened more than 90 degrees, so the answer has to be larger than 90 degrees. It's not going to be 50, because 50 would be smaller than 90 degrees. It would be more closed. So my answer is going to be 130 degrees because it's more open than a 90-degree angle. All right, what I'm going to do now is I'm going to put the protractor on this angle for you. I'd like you to look closely at it and see if you can figure out what the measurement of that angle is. I'll tell you, because I know the numbers are small, this line coming out this way goes right to the 0. The line coming up right here is pointing at two numbers, 20 and 160. So you have to decide, is the answer 20 or is it 160, and fill it in on the blank right there. Pause the video until you have it filled in, then turn the video back on. All right, so the correct answer is, of course, that's a 20-degree angle. It's not going to be 160 degrees because this angle that I'm measuring looks like this. You can see it right here. Let me move this out of the way. Look at how small this is compared to a 90-degree angle. Well, if this 90-degree angle is here and the angle I'm measuring is way down here, that's going to be less than 90 degrees. 20 makes sense. 160 makes absolutely no sense for that angle. Okay, I'd like you to do 4, 5, and 6. Pause the video, turn it back on when you're ready for the solution. All you have to do is pick the number of these three that you think matches up with the measurement of the angle in the picture. Pause the video, turn it back on when you're ready for the solution. All right, again, if this was 90 degrees, it would be about right there. And this is more open than 90 degrees. And it's not just barely more open at 94. It's definitely not 47 because that would be smaller than 90 degrees. It's going to be more like 141 degrees. And I can pull this down and show you. Here is there, and then it's coming right out here, and that's going to the 40 and 140 out there on the protractor. Okay, number 5, you should have picked the answer. 90 is right here. It's just slightly less or more closed than 90, so 85 makes sense. It's not way more closed than 90. It's definitely not bigger than 90. How about this one? This 90 degrees would be going right up here as a right angle. This is more open than a right angle. These two are both less than 90 degrees, so the only one that makes sense is 125 degrees. All right, and there's our answers. Last, let's get rid of that. Last but not least, taking a look at 3 different kinds of triangles. It says congruent figures have the same shape and size. Don't forget that. Equilateral, all 3 sides are congruent. An equilateral triangle, and there's a Rockin' the Standard song to help you remember this, all 3 sides of the triangle are the same length. They're all equal to each other. That's not spelled the way equal is spelled, but it's really close, and that makes it easy to remember. Isosceles has 2 sides that are the same length, and the other side is a different length. All of these are isosceles triangles. And the way that I remember that is that you have an S, an O, and an S. So I kind of go like that and make a little TP connecting the S's, reminding me that 2 sides of the triangle are the same. Scalene triangle, none of the sides are the same. Long, medium, short. This one's got long, medium, short. Long, medium, short. None of those are the same between the 3 sides on each one, and so these are called scalene triangles. A snake is kind of scaly, and most people get grossed out by snakes, and that might help you to remember that scalene triangles are evil, they're no good, and they have no sides the same. And again, learn the Rockin' the Standard song, and it'll be real easy for you. The symbol, now onto this page, the symbol for referring to a triangle is a small triangle. So this triangle right here we would name as triangle BCD. All right, little triangle symbol, and then the letters that make up that triangle. The sum of the angles of any triangle is 180 degrees. How does the sum of the angles of a triangle compare to the sum of the angles of a rectangle? Well, that's a pretty simple question. And again, let me explain this to you. The 180 degrees means that if I add up all these angles, the measurement of that angle, the measurement of that angle, the measurement of that angle, I'm going to get 180 every single time, no matter what the triangle looks like. Even if the triangle looks like that, and I add up the measurement of these 3 angles, I'm still going to get 180 degrees. So pause the video, answer this question, turn it back on when you're ready for the solution. Okay, so the answer is that a rectangle sum is larger, or something like that, because rectangles angles add up to 360 degrees. Thanks for watching.